News Unpeeled, thanks to 3dprint.com. And today we find out that Hexagon is very, very serious about 3D printing indeed. You know, the software slash QA slash measuring slash everything kind of company has previously put 100 million, a surprising 100 million into Divergent, which I'm a little bit I was a little bit surprised by that, let's say. And now the company has bought CADS. CADS is a company that makes a kind of automated wizard-driven kind of planning software, planning kind of semi-nesting kind of build prep kind of software for laser powder bed fusion. They do hatching supports, that kind of stuff. It's kind of like an entry level position, kind of like my first 3D printer, kind of my first powder bed fusion system kind of system. It competes, of course, with the all-encompassing almost Magix that kind of dominates our market. And yeah, Hexagon just bought that company, and it doesn't seem like it's a real direct threat to materialize at the moment, but it's really, really clear what Hexagon is doing. Hexagon is just going to cobble together, a dozen 3D printing companies, these companies with all their build prep, optimization, QA solutions, and just going to cobble them all together in one integrated 3D printing solution. I think that's kind of what we're seeing happening at the moment. It's got some offerings right now in 3D printing of its own products. And CADS itself has worked with AOS, E+, and also Hexagon itself for a couple of years. It's a 21-person startup. It's Austrian. And, I think CADS is an interesting play if like the one-click metal machines and all these other kind of like 100K machines are starting to proliferate. Then all of a sudden your magic seat is a kind of considerable part of the outlay for buying one system. So in a market where that kind of entry level metal powder bed fusion and powder bed fusion systems are growing very quickly, CADS and then kind of this entry level offering can really play a role. Because like you're not going to pay like a fifth of the purchase price of your machine on software. That's just not going to make sense to a lot of people. So I think this is a good play for the long term. And yeah, it's clear that Hexagon wants an integrated solution, which will make them, next to Autodesk and Materialize, a really, really big player in the future of additive if they continue to try to purchase and offer the whole tool chain. The next news is from Pilot. Pilot is a Netherlands-based company. They make titanium bikes, very expensive bikes, like 4,000, 6,000, 7,000 and up euros. Racing bikes, gravel, that kind of thing. And their whole idea is to use titanium. Now they're making a 3D printed titanium bike. Now, I know there's been a lot of 3D printed titanium bike news. A lot of people are doing sheet posts, cranks, handlebars, all sorts of components. And there have been some ones that do lugs that then are custom geometry lugs that you then combine with standard tubing or cut to size tubing, which I think is still a really smart approach. What these guys are doing is they're printing the entire frame. So they made it in 3 different components, and they then join those 3 components to make this frame. So the idea eventually, and I'm not entirely sure how realistic it is for them to want to be able to do this now, but hey, maybe in a number of years they could really get this together, is to have custom rider geometry. The idea, is I can come in, I get a scan, hook myself up to power meter stuff and all this other stuff, and then I get the bike geometry exactly for me, or even exactly what I want to ride, or my comfort level, how far I want to, sit on the bike, and how much down I want to sit on the bike, and I get a custom geometry just for that bike in some kind of novel way that means that we can change more to make that uniquely comfortable for me. So I think it's an interesting approach. Generally, Pilot's approach in making titanium bikes is quite more interesting because it's a very durable, very tough, very strong material. All these other really, really expensive bikes, typically there's some steel, but typically there's some aluminum as well. But typically they're all carbon fiber. And carbon fiber is, of course, a plastic. It's a polymer. It's brittle. As we've learned recently, it doesn't have that much compressive strength. There are some issues with that. It's also not a very sustainable material. So I think Pilot, by wedding its future to titanium and wedding its future to that one material, has a really interesting play here. And of course, it's a beautiful market to be in, to be able to sell a $7,000 bicycle. Even though, when they do sell that bicycle, they have a lot of components from other companies. Now, of course, the group sets and things like that come from Shimano and other companies. But there's a lot of components that come from, for example, companies like Bolt Dragger. That's actually part of a much bigger company, but FSA, Dedakai, and all this. These kind of smaller components can now be integrated into the frame. So if you're looking at this from the perspective of a company like FSA that make these little components that are married to the frame of the bicycle, this might actually spur them to use more additive manufacturing themselves. So I think this is actually kind of a very interesting play. The bike is called the Siren. We have no idea of pricing. It's going to be scary expensive. That's my prediction. It's going to be terrifyingly expensive. You can get a pretty darn good Camry for this bicycle. That's going to be my secondhand Camry, but you can get a pretty darn good Camry for this bicycle. Is my prediction. And it's just the future. I don't know. I definitely think that one of the biggest industries for 3D printing going forward is biking. Bicycles, high-end bicycles, bike components, custom bike components. Sure. I just don't know if we're going to print the whole frame because I don't know if the economics of this makes sense. To me, this individualized lug thing plus cut pipes is going to be much cheaper. But maybe they could make very, very really individually adjusted, very unique geometry that could give you a much more comfortable ride with exactly the right dampening you need, exactly the right kind of position and stuff like that. And that could really add to a lot of people's experience. This is a bit of a money no object market. It's really great if you do really well, like the Cervelo and the Colnago players of this world. And it's also really good if you're a niche company that is able to be tight on costs and tight on outlay and still make a lot of custom bikes. So, this could be a very good niche product for them, and we could be a niche technology for them. And it could still really, really make sense. We don't have to be the future of all bicycles. We could still be, a technology that's used some of the time by some of the players for this to be a big application for us and for us to be a relevant technology for a lot of these guys. So, I think this is super, super, super interesting news. The next thing is something that is a news from GCAN Aerospace and Materialized. So a while back, there was a $17.8 million project with Oak Ridge and GCAN Aerospace did around a DED. So they made a DED cell. So DED, direct energy deposition, really great technology, but you need to post-process things. Now, what's happening already in Optimec and other companies, Siaki, have been working on this for a while, is these things have been used to repair a ton of turbine blisks. So imagine all the turbine blades you can make in the world. They get old, they get worn down. You print new material on them, then you sand material off, or you post-process it to reduce this material, so you get a turbine blade again. You need to do this with DAD because the feedstock is cheap, the process is kind of accurate, and then you need to kind of file it down in some way, mechanically finish it in some way to get it to be the right shape. Now, doing that means, gets you some economies of scale. But in order to really benefit the cheap feedstock and this cheap process and the ability to build a lot of material per hour compared to traditional additive processes, you need to automate this whole thing. So you need to put this thing in a cell. And this is what's happening for antenna for mobile phones. It's been happening for some electronics. And it's been happening with aerosol jet. It's been happening for turbine blisks, turbine blades, and other kind of similar things for military and aviation. And now GCAN and Materialize want to work on industrializing this process, doing the qualification, the certification for aerospace parts. Now, this is, of course, a great thing. This is really smart for both companies to work together on this. But the other thing is that I want to point out is that we had an interview on 3D Pod with Fried, and we were talking about the biggest 3D printing applications, the next 10 million parts. And Fried brought up this electric aircraft and these personalized aircraft. And I was intensely skeptical about this because I just thought this was like a super niche thing. I really can't really super imagine a future where a million people will have an aircraft. And I also don't really imagine why that would be good for anyone. But anyway, we could just all, instead of all being on the road at 9 o'clock in the morning, some of us can go at 9, some of us can go at 10, and we'd probably solve most of the problem anyway without having to build an aircraft for everyone. So I really didn't understand this completely, but Fried did, and Fried is way, way, way smarter than I am. So I took a really interest in this, and I started looking and reading into it. And by golly, this may very well have a niche and have an industry, and it might very, very well get really big. And also, it's kind of like a through the servant's entrance kind of way into the aviation market, rather than trying to battle out to be an Airbus supplier for the most taxing 10 years of your life. This is super not fun, by the way. You could, work with startups, work on much more emerging things and get into the market much quicker. So I think it's a really smart approach. I think we will have lots more industrial applications driven by DED, and I think this is something that's overlooked. A lot of our market is super powder bed fusion driven. But people are like, oh, 3D printing is powder bed fusion for them. It's just synonymous. But if we're looking at wing spars, if we're looking at chassis components for cars, large industrial components for oil and gas, DED is a much better technology to use. And what we have been seeing is that GKN by itself is making progress. They went from 8-axis motion, which already super complicated, 20 kilowatt wet laser that could make like about 1 meter by 2 meter parts, right? That was the cell 2. Then went to the cell 3. This is able to deposit material into a 5 by 6 meter by 2.5 meter object. Also with a 10-axis, this time with a 10-axis motion, 20 kilowatt laser. So imagine the possibilities of just, using this in a really versatile way to deposit things in a kind of a really unique tool path to make these objects relatively inexpensively for aerospace. I think it's a wonderful market. I think it's really smart. And I know this news came out kind of yesterday, but I wanted to point it out because I think if you miss this, you maybe read this, you're like, oh, GCAN and materialize, yeah, whatever. They're going to sign something. No, this is much more important than that. I mean, we're talking about industrializing DED to move additive into much newer areas, much bigger parts, and to do this in a way that ends up having, flight ready parts. So I think this is something that maybe is a bit overlooked. So that's why I pointed it out again. Anyway, so my name is Joris Peels. This was thanks to 3dprint.com and other 3D printing news Unpeeled. And I hope you found this valuable and useful. Spread the word.